can't hear it.
Okay, here we go. So, the fundamental theorem of calculus. We need to figure out the part 1 and part 2. So, here's part 1. It's a very important fundamental theorem of calculus. Part 1 is this. What does this stand for? D over dx. So everybody put derivative down. Derivative. What does this stand for? The integral. What is it? Starts with a P.
Period. The cycle.
Position. So basically, this is the rule. If you take the derivative of the position, aren't you just negating each other?
You get one.
Aren't you just going to negate each other if you take the derivative of the integration of the velocity? Isn't this the velocity? So let's say you integrate the velocity. What are you back to? But what happens if you take the derivative of the position? Aren't you back to where you're at? Aren't you back to what you started with inside of that? But remember that rule that says if this is the dummy variable t and you're integrating from a to x, your final answer needs to be in terms of x and not in t, right? You can't have the same letter, right? You have to have two different letters and you are done. So if you see this on the AP test and you see basically what does this stand for? The derivative. But what happens when you integrate the derivative? Don't you get to position? What happens when you take the derivative of the position? Again, everybody understand how this works, you guys? So, what's the answer to this problem is the cosine of x. All you do is you substitute in place of the t, the what? The x. I can prove to you that it is that. Does anybody want me to prove that I went in a circle? I did it, and I worked it out. And I proved that it makes the exact same answer. This number, I'm just gonna, if you integrate from a negative pi to x cosine of t dt, if you integrate cosine, you're gonna go back to sine, right? From a negative pi to x, right? Everybody knows that the derivative of sine is cosine. You learned that a long time ago. What they did, this is really important that you know this, they picked a number that will always cancel out. So the only thing you have left is the variable what? So you always go top minus bottom, right? You put the top in place of the t minus the bottom. And if you take the sine of a negative pi, guess what it turns out to be? 0. So we integrated and got the sine of x, correct? But now you have to take the derivative of sine. What's the derivative of sine? Cosine of x. So we just go in a big circle. What you need, there's a little bit of twist to this, but it stays this easy right now. You need to know that whatever they pick down here probably cancels out. And this variable gets replaced. Everybody got it? So this will be an easy one, and then the next page it's going to get harder. This is called the fundamental theorem of calculus part 1. It's a very important theorem that you need to recognize on the AP test. So, you're integrating from 0 to x, 1 over 1 plus t squared dt. What you need to know is that this is the velocity. And if you integrated this, you're going to have to learn this next chapter. When you integrate this, this is tangent inverse. I bet you don't remember that, but anyway, all you have to recognize is these two are going to negate each other, and all you have to do is put in place of t what? X. So what's the final answer? 1 over 1 plus x squared, final answer. But it's going to get harder, and this is what they're going to do on the AP test. Any questions on the first two? The first two in the book are going to be this easy. Now the next one. dx integrating from 1 to x squared cosine of t dt. Okay, where does it get harder? Again, you see that it's a derivative and you see that it's integration. You're going to put the cosine, but in place of t, what are you going to put in place of t? X squared. So far, so good. You're not going to understand this until we get to the next. You're not going to understand this until you get to the next chapter, but you also have to take the derivative of the limit, of the highest limit. What's the derivative of x squared? 2x. I'm going to put it out in front. Final answer. You are doing that in the first two problems. You didn't know you were doing it because let's go back to the first two problems. All I did was replace my t with an x, but what is the derivative of x? 1. So you're doing it, you just didn't know you were doing it. Okay, one more, and then we'll get into a harder one. If you see d dx, and then you see integration, and then you see this, there's something wrong with these. What's wrong with this? Flip it, so don't we have to flip it? The number has to go on the bottom, and the left variable goes on the top. So, if you see this on the AP test, and you see d over dx integrate from 5 to x, what else do I have to put in the problem? Negative somewhere. Can I put it here? We're going to come out with a negative. And in place of my t's, what am I going to put there in place of my t's? X. 3x sine of x. Final answer. The derivative of x is 1. Final answer. Recognize that this is the part 1 of the fundamental theorem of calculus. Okay, now it's going to get a little harder, and this is where it gets harder. D over dx integrating from 2x to x squared, 1 over 2 plus e to the t dt. Okay? The fundamental theorem of calculus says that there's always a what at the bottom, a number, a constant, and there's always a variable up there, right? So what we need to do is that one property that you learned yesterday. I'm going to turn my page here. I'm going to break this up and make two different integration signs with a plus sign. And I'm going to put 2x down here. And I'm going to just use the dummy number 0. And then I'm going to put diagonally across from the 0 another 0, and I'm going to integrate from x squared. Is it exactly the same thing? If these two canceled out, are you still integrating from 2x to x squared? Right? Okay, is it still 1 over 2 plus e to the t dt, and 1 plus 2 plus e to the t dt? But you still have d over dx in front of them, both of them. So the first one was easy. The second one, you had to make sure you took the derivative of the top. The third one didn't have a number, and you need to give it a number, right? So I needed to break this up into two different integrations. There's something wrong with the first one. What's wrong with the first one? Yep, the 0 needs to be here, and the 2x needs to be here. Okay, let's see if you guys can figure out what to do now. So if you saw this, the answer is going to be a negative, correct? Because I flipped it. Doesn't the d over the dx and the integration going to negate each other? So isn't it just going to be 1 over 2 plus e raised to the what power? 2x, where we see the t. But we have to do one more thing on this problem. What's the last thing we have to do? Find the what? Derivative of the top. And what's the derivative of the top? 2. You can stick it up here. You can stick it out in front. You know what I'm talking about, kind of like the one I was showing you over here. The book puts the 2 on the top. You can put it on the side, it doesn't matter. The next one, plus. Is this one set up perfectly? Is the number on the bottom and the variable on the top? And don't these two negate each other? So isn't the final answer going to be 2 plus e raised to the what power? 2 plus e raised to the x squared. But you're not done yet. You need to also take the derivative of x squared, which is 2x. And again, you can put a 1 on the top and put the 2x on the side. I don't care. The book's not. No, you don't have to put them together. You can't. Forget. They don't even have a common denominator anyway, so you can't put it together. Any questions? It's a very basic property if you know how to do the property. Any questions on it? Okay, moving on. The fundamental theorem of calculus part 2 is the solving part. So if they tell you to solve it, you already know that you've already done this before, so this is just review. So, do you see that there is no d over dx in front of it? Everybody see that? you're just going to integrate x to the 3 halves. And how do you integrate x to the 3 halves? Isn't that x raised to the 1.5? So can't you just add another 1 to it, which makes 2.5?
You skip a slide.
Did I? Okay. Yes? That one? This was 7. I mean, this was your page.
Yeah.
I'll come back to it then. It's no big deal. Okay. Now I've lost what I'm doing right here. Okay, so I added 1, and now I got to divide by the same thing. This is important. I'm writing this the right way so your professors don't think who taught you this. You integrate, and after you integrate, you make a straight line after it. This is important for next year if you take this. From 0 to where? To 4. Will the 0 do anything to the problem? No. So whatever 4 to the 2.5 is divided by 2.5 is 12.8 if you care. Good? So the second, it's called the Fundamental Theorem of Calculus Part 2, tells you just you can solve the problem. And same thing with this one. Do you guys remember what secant squared x, what derivative that went to? You guys remember that? Wasn't it cotangent? Didn't tangent make secant squared x? Or no, did I do that wrong? Yeah, that's right. So this is a negative cotangent of x from 5 pi over 6 to pi over 6. They're giving you a little taste of a trig. What you should do is this. Take out your you don't have to take out your formula sheet, but I'm just going to show you here. What do we have to know now is instead of going from left to right, you need to know how to go from right to left now, right? And that's more in the next chapter. But you can look on here and it says, where is it? Yes. Negative cosecant squared is cotangent, and it was just a positive cosecant squared, so that's why it's a negative cotangent. But instead of going left to right on this formula sheet in chapter 7, we need to know how to go from right to left. This whole thing. So that's what we're getting to. Okay, good review. This is a non-calculator one on the test. I'm hoping you know that pi over 6 is 30 degrees, correct? Pi over 6 is 30 degrees. There's 5 30s, which make 150, right? Opposite of 30 is a negative 1. This is the square root of 3. No, this is a positive 1. And that's 2. What is the cotangent of this picture? Positive square root of 3, isn't it? It's not opposite over adjacent, it's adjacent over opposite, and you got a negative inside, so it's going to be a positive square root of 3 minus the lower one, which is in this quadrant, minus the square root of 3 minus a negative square root of 3 because of that negative sign, right, which makes 2 square root of 3s. Today, they might give you basic ones, and you should be able to go backwards by looking at your formula sheet. So, the 1 over, this one is on here too. Where was it, right? That one is on here too. Instead of t, though, they used u squared on here. So, everything, you should be able to figure it out by looking at your formula sheet. Okay, this screen right here was your page, and you already know this. I've already talked about this, but just bring this up one more time. To find area, I think they say, this is where it gets kind of confusing on the test. Do they mean net area or total surface area? You know what I mean? So area is total area. You're going to partition your A and B at the zeros. You know what I'm talking about, where it crosses the x-axis. You're going to integrate the two sections, and then you're going to take the absolute value because it's always the positives, right? If they want you to find the net area, you consider positives and negatives. We've already talked about this, correct? We've done this many times. I'm going to show you a shortcut on the calculator to come up with these two answers too. So, okay, moving on. Now we're here. Find the total area and the net area. So, if they ask you to find the total area and the net area, we're going to integrate from a negative 2 to a positive 2. 3x squared minus 3bx. We will use a calculator, but I want to just set it up to show you what it looks like, but I'll show you how to show a shortcut too. So, on the test, the first thing they want you to do is to graph this, and I'm just going to tell you, put a 1, 2, 3, and put it at 0, negative 3, and go out to a positive 2 and a negative 2. And it intersects at 1 and a negative 1, and it's a parabola facing up, so it looks something like this. They want you to find the total area and the net area. And I'm going to show you with a calculator and without a calculator how to come up with two answers. And I know you've done this before, so this is just another day of seeing this again, right? You always go from that curve to the x-axis. So is this one of the areas that we need to figure out the area of? How about this? Are we going to find this? Are we going to find this area? No, it's from the curve to the left. To the x-axis. Everybody see the difference? Here's the other area. And to the curve to the x-axis is the other area. So, you could integrate from a negative 2 to a negative 1, and I'm just gonna make this f of x. I'm just gonna make this f of x dx, so I don't have to keep writing down the same equation again. I can integrate from a negative 2 to a negative 1, and you can see that you're gonna get a positive answer when you do it, correct? You're gonna get a positive 4. So write that down. Could you plug that into your calculator and get that answer? Yeah. And then when you integrate from a negative 1 to a positive 1, f of x dx, you can see that that's going to be a negative, and it ends up going to be a negative 4. And then when you integrate from 1 to 2, f of x dx, you're going to make a positive 4. So, to find the total area, and to find the net area, I think you guys know how to do this because I've already talked about it. Total area is positive 12, correct? Total area is a positive 12. And net area is 4, right? Okay, I just gave you the answers, correct? I just gave you the answers. And I figured out positives and negatives. What was I going to tell you? But if you did it the long way, you would have to integrate this. 3x to the second, you add 1, divide by 3. Isn't that x cubed? Isn't the antiderivative x cubed? Isn't the antiderivative 3x? And then you would have to integrate from a negative 2 to a negative 1. How long does it take us to do all of this work to come up with the positive 4? Will this take a while? To plug a negative 1 in here, minus plug a negative 2 in here to get the positive 4 on the AP test? It'll take you a while. Yeah. Did I do it wrong? These two go away. 4. Right? You know how long it's going to take you to get 4 on the AP test, but everybody know how to get 4 on the AP test? Anybody confused on how to get 4 on the AP test? The top number minus the bottom number, and you should get 4. Okay, now on your calculator, do you have an FNINT on your calculator? I write this down at the bottom. If you integrate from a negative 2 to 2, that function, you are going to get the net area, which is what? 4. If you plug that into your calculator, everybody knows how to use the FNINT, you get 4, correct? This does not give you the total surface area, that total shaded area, correct? How can you come up with the total shaded area? It's this easy. Negative 2, 2, and all you have to do is put whatever your f of x in an absolute value. You know your absolute value button on your calculator? It's under math, under numbers, it'll say absolute. If you put this in an absolute value symbol, you're going to get 12. Pretty slick, isn't it? Pretty slick. Because everything that was negative got flipped. Everything that was negative flipped up to positive, and these would all be positive numbers. That's pretty slick if you know how to use that on your calculator, right? So, there are two ways you can do this. You can do it the long way. Because on the AP test, you might have to do it the long way, so you need to know how to do it the long way. And you need to split it up exactly where it crosses the x-axis at. That's why you have to graph it. Or, if they ask you to do it the shortcut way, that absolute value button is going to be a huge plus for the test. Got it? If they ask you separately what each section is, though, you would have to do it the long way, right? So, any questions on that part? Wake up, Jake. Come on, wake up. Okay, moving on. Page 307, since you guys don't have I'm just going to put it up here, since you don't want to open up your book, but this is what it looks like. 1, 2, 1, 2, 1, 2, 3, 4. This is problem number 46. I think you don't have to do this problem, but just in case you see this on the AP test, at 1, 1, you're going to put a dot. Sorry, 1, 1, you're going to put a dot. And at 2, 4, you're going to put a dot. Okay, so if you see something like this on the test, and this is what it looks like. It's concave down here, and then it's concave up here. And you're integrating from 0 to 2, and you're trying to figure out the area underneath that curve. And they're going to draw a little arrow to this little section, and they're going to say that this equals y equals the square root of x. Does that kind of look like y equals the square root of x at the beginning of a swoosh, right? And then this spot right here is a totally different equation. It is y equals x squared, which kind of looks like y equals x squared. Could we find the area underneath this curve if we wanted to? Would we have to split it up where the two functions, right? So you would have to integrate from 0 to where first? 0 to 1, and the function is the square root of x dx. And then you would have to integrate from 1 to 2, but it's a totally different function, which is x squared dx. I'm going to show you the long way, and I'll tell you the answer, but could you plug this into your calculator? Yes, but isn't this x to the 1 half power? If you add 1 to half, you're going to get x 1.5 divided by 1.5, correct? Or if you don't like, you could put 3 halves and 3 halves. Integrating from 0 to 1. When you plug a 1 in, aren't you just going to get 1 over 1.5, which is 2/3? It's 1 over 3 halves, so basically you're just flipping the 3 halves to make it 2/3, if everybody understands that. This one, if you integrate, it's x cubed over 3 from 1 to 2, and I'm going to show you this one. When you plug 2 in, you're going to get 8/3 minus the bottom, which is 1/3, which gives you 7/3. And the 2 added together would give you the area underneath there, and 2/3 and 7/3 makes 9/3, and 9/3 is 3 units squared. Couple more things and we're done. Okay, the average daily inventory. Do you remember the average mean? Remember that? Or the average value theorem from last section, 6.3? 6.3 was the average value theorem. Do you guys remember the formula? It was basically 1 over b minus a from a to b sum f of x dx, correct? They're just showing you that this is a business. You might, if you're going to be a business major, you have to take calculus. It's called a short course calc. And this would be in the business book for calculus. What's the average daily inventory of whatever their concept is? And here's the story problem. Suppose a wholesaler receives a shipment of 1,200 cases of boxes of chocolate every 30 days. Here's the key word. Find the average daily inventory, right? When you hear the word average value inventory, you're just going to go 1 over every 30 days. You're going to integrate from 0 to 30, right? Every 30 days. And what's going to go 1 divided by what? 1 divided by b minus a, which is 30, right? And they're going to give you some equation that you're going to know. If you're not going to be an engineer, you still have to take some type of an AP class that deals with business. So instead of finding the area where they're equal, that would be calculus, we're doing inventory. It's the same concept. The key word is what? Average daily inventory. Is that an easy problem then? I'm just gonna give you the answer. Isn't it 1,200x minus, add 1, that's 2 divided by 2, isn't that 20x squared? From 0 to 30. You come up with that answer, multiply it by 1/30th, and you're going to get 600 boxes. Why am I showing you this? Because obviously it's in the book. It's going to be on the test at the end of the chapter. It's the same concept. 6.3 and 6.4 are kind of nice. It's a lot of repetition, isn't it? This is repetition. Solving it, integrating is repetition. The only thing that isn't repetition was the first part 1 of the fundamental theorem of calculus. That's the new thing. Was this hard? This new one? It's not hard at all. Okay, last part. Last part. Really, really, really important. Do not fall asleep on this problem. This is a free response question on the AP test. Really important. So this is it. Then you got the rest of the hour to... Okay. Are you guys ready to go? Everybody watching and everybody listening. Do you notice that they're going to give you on the AP test some type of an equation like this? You need to decide before you start what type of graph this is. Because did we study graphs? Did we study the position graph? And did we study the derivative graph? Is the derivative graph just as important as the position graph? You don't have to write this down. We got some time. But, let's do this. Let's just review this from chapter 5 really quick. I know it's the same thing. But this is f of x, and this is the derivative graph. Even though it seems to be the same thing, is it the same thing? No, these are not the same thing. So, if they asked you on this graph, what's the minimum value? Could you tell me what the minimum value of the position graph is? Minimum value, correct? If they ask you where it's increasing or decreasing, could you tell me on the regular graph where it's increasing or decreasing? Yes. Good. On the derivative graph, everything above the x-axis is important. This stands for slope, right? The derivative stands for slope, right? It means that on the original graph, from a negative infinity to like a -1, isn't your graph increasing? And everything from 1 to infinity, isn't your graph increasing, the original graph? And everything below the x-axis means where the original graph is decreasing. And then there's some other things that are important. If you went from positive to negative on a derivative graph, what's so important? What's on the original graph? What's happening? A max. And there's a min. Did we study acceleration graphs? No, not a lot, have we? We studied this type of graph and this type of graph, right? So, here's the question here. This is important, so really watch. are going to give you this. S equals 0 to t f of x dx. And they want you, they're telling you that this is f of x. They're telling you that that's f of x. Do you guys have that written in? Put f of x on the top. And this is where it gets complicated. Everybody listening? You need to decide if this is the position graph or the velocity graph, because it makes a big difference, correct? All you have to do on the AP test, if you're listening, this could be a huge key for you to do really well in the free responses. You look over here. You look over here, and you see that there's f of x dx underneath the integration sign. So you know exactly what this graph is now, even though it doesn't say it. Is this stand for velocity underneath the integration, or does that stand for position? That's a velocity graph. This is a derivative graph, even though it says f of x on there. Everybody hear that? This is a velocity graph. When you integrate this, you'll get some S answer, and S stands for position, correct? So really important that you know that this isn't f of x position, it stands for velocity. Ready to answer the question then? What is the particle's velocity at t equals 3? What is the particle's velocity at t equals 3? Well, this is the velocity graph. Can't you just look at 3? Isn't the answer 0? Keep awake. Particle's velocity at t equals 3, it's going to be 0 for your answer. Okay? Now they're asking you about the acceleration. Isn't that the derivative of this graph? Okay? Is the acceleration of the particle at t equals 3 positive or negative? Kind of a slope is there at the 3 marker. Is that a positive or a negative slope? Positive. I'm just going to circle it. But if you don't know what kind of graph it is, you could get all of these wrong on the test, and this is worth 9 points on the test. So if you don't know what kind of graph it is, you could be really lost. The next one, now they asked something about the velocity, they asked something about the acceleration, now they're going to start asking something about the what? Position. What is the particle's position at t equals 3? And you're going to go, heck, I don't know. There's 3, but this is the velocity graph. And I know when I integrate, if I integrate this, it turns out to be s, which is the what? Position, right? So they want to know what is the particle's position at t equals 3. When you integrate, what are you trying to find when you integrate? What have we been finding? When you got an answer, what does it stand for? Area, total distance traveled, area, position, all the above, correct? Doesn't all of this, when you integrate, stand for position, area, total distance traveled, all of that? So, if they ask you to find the particle's position at t equals 3, all you have to do from that curve from 0 to 3, all you have to do is find the what? The area, right? Can't we just find the area when they ask you to find the position? There is no equation, but doesn't that make a triangle down in the bottom? So you don't even need to integrate. All you have to do is 1/2 base times height. What? Wake up. 1/2 base times height, write it in there.
Okay.
Between these two.
Yeah,
Isn't the base 3 correct? And the height is what? Oh, yeah. 1/2. Oh, sorry. I knew something was wrong. We're counting by 2s. See that? I didn't see that there until I got my answer and went, wait a second, this isn't the same answer that they have. So it's a -6, sorry. It's a -6, correct? Why is it going to be a negative answer and not a positive answer? Because it's below the x-axis and your area would be negative. And -9? Yeah. See why this problem is so important how to read it? Really important how to read it. Don't say, I don't know, this is a velocity graph from 0 to 3. I don't know how to find the position. I know that this is velocity and I can maybe answer questions about acceleration, but how do I go backwards? You go backwards by finding area. That's how you go backwards. At what time during the first 9 seconds, I'm counting by 3s, does it have its smallest value? If this is the derivative graph, how do you find the smallest value? What's another name for smallest value? Starts with an M.
How's that bucket set?
I know, switch it to smallest. I'm sorry. Yes, switch it to smallest. Typo. Yes, Isaiah, it's the minimum value. And how do you know? Someone's going to say the minimum value is way down here because they're thinking it's the original graph. But the minimum value is when the derivative goes from negative to positive. So at exactly 3. See, do you see how everything accumulates from what we've learned in other chapters? And the last question, approximately when is the acceleration 0? Approximately when is the acceleration 0? Yes. Horizontal slopes have slope of 0, correct? Everybody knows that slopes at it. So approximately right up here, if you look in the book at this problem, it's a straight line and then it turns into a parabola in the book, and that's obviously about the 7 marker, the 6.5, or somewhere around there, around the 7 marker. And that's why I wanted to make sure you know how to understand how to read a graph like this. And that is about it for today. So.